this video, we'll be looking at the pre-calculus algebra topic of distance and midpoint formulas and the formula for a circle, the equation of a circle. To start with, what a neat opener. We've got what we would now call a Ferris wheel from the Columbian Exposition, the World's Fair in Chicago. The picture I have, that was in 1893. Picture I have here for you isn't from 1893, it's from the 1904 World's Fair in St. Louis, a Louisiana Purchase Exposition. And did you know that observation wheel, as they called it, they hadn't named it yet after George Ferris, but that they refer to it as the observation wheel. That observation wheel was moved from Chicago to St. Louis for the St. Louis World's Fair. And that's what I have pictured here. Really neat piece of St. Louis history. So in this section, let's start with the distance formula. Let's say we have these 2 points and we want to find this distance between them. There's a formula we can use to find that distance, and it's based on a formula that I'm going to guess you probably know, because so we're looking for that red distance, right? But if we called the length of this green line A, so it's just the difference between the two x's, and let's call this blue line B, and because we're set up on a right triangle, I'm going to guess you can probably recall the formula you could use to find that length C. Do you remember that? A squared plus B squared is equivalent to C squared. And if you wanted to find the length of C, we could do the square root of both sides and we'd get A squared plus B squared. Now usually when we do the square root to release this square, the C squared, to solve for C, we would say the plus or minus. But because we're talking about a length, we're not going to be concerned with that minus, right? So we can delete that minus and just say this length C, which we could call the distance, we'll call that the square root of A squared plus B squared. So it's rooted, this distance formula, it is a little bit more complicated than that, because what we'll do next is we'll say that A is a distance between the two x's. So what do we do? To get this distance formula, we're going to take the distance between the two x's, and you know what? It doesn't even matter which order we take them in, because what we're going to do to that difference, or the distance between them, between the two x's, is we're going to square that length. That difference, we're going to square it. If it was positive because we did the larger x minus the smaller x, then it stays positive. If we mix them up and did the short one minus the long one, so this x minus this x, x1 minus x2, it wouldn't matter because we'd get a negative difference, but when we square it, it comes out positive, so that wouldn't matter. And then we're going to add that to the difference between the square of the difference between the two y's. And that's the distance formula. Do you see how it relates to the Pythagorean theorem, that a squared plus b squared equals c squared? By the way, I just can't help myself but bring up 2 really interesting pieces about the Pythagorean theorem. When we have this a squared plus b squared equals c squared, the Pythagorean theorem, we know it's a right triangle. It's not any 2 sides, it's got to be the 2 legs, right? The A and B have to be the 2 legs, or the 2 shorter sides. And the C in the Pythagorean theorem is the hypotenuse, or the longest side, but really entertaining. If you go back and watch this clip, And you can do a search and find it on YouTube, the Scarecrow, when he was given his brain by the wizard. He immediately spews off the Pythagorean Theorem to prove how brilliant he is, right? But what's interesting is he actually did the opposite. None of the writers or the actors or the camera people seemed to notice that he spewed off the Pythagorean Theorem incorrectly. So if you watch that clip, you can find the many different errors he made when he stated the Pythagorean Theorem. Now, the writers of the hit adult cartoon, The Simpsons, made fun of the Scarecrow when Homer Simpson found a pair of smart people glasses in a public toilet, by the way, and he puts them on his face. He instantly is brilliant, and he spews off the Pythagorean Theorem, but he makes the same error the Scarecrow had made decades earlier. But someone a few stalls down yells at him and corrects him and calls him an idiot. So really fun clips about the Pythagorean Theorem. If you haven't seen those before, I'd recommend them. But let's look at this distance formula just one more time if we have an actual grid that we can put it on. So let's say that we've got this point 1, 1 and 5, 5, and we want to know how long is this. Well, we would just take the difference between the two x's, right? So 1 minus 5 or 5 minus 1. If we did the absolute value of that, we'd get a 4. And remember, we're going to square that number, so it doesn't matter if we have the negative or the positive. And then let's go up here and say that this is the other point. If we wanted to find how tall is this, the y's, it looks like the y at the top is 6, and at the bottom it's 1. So 6 minus 1, or 1 minus 6, give us an absolute value. Here, let me say the absolute value of those, either one, is going to be 5. So it looks like our A and our B are 4 and 5. So C is going to be the square root of 4 squared plus 5 squared, right? Because C, let me make sure you've got the C squared equals A squared plus B squared. So C squared is 4 squared plus 5 squared. So that's 20, 30, 41. And then the C, the actual length, here's C, this length right here, which we can't count by how many increments it is, right? Because we're going it diagonally. But the length of that is going to be the square root of 41. And we could use a calculator to get an estimate of that square root. When I did the square root of 41 on a calculator, I got that it's approximately 6 4/10. That seems appropriate, right? We know it's bigger than 4 or 5, but not hugely different, right? So there we go. There's the Pythagorean Theorem. And that's also what we can translate over to get the distance formula. So do you see that the difference of the x's is like a squared? The difference of the y's is like the b squared, and the distance is the c. So you could use that you already know the Pythagorean theorem. C equals the square root of a squared plus b squared, to bounce off of as you memorize, as you learn the distance formula. But the distance formula gives us the distance between 2 points. What's helpful about this distance formula, though, is that we could take 2 points that aren't even forming a right triangle, and it'll still work. midpoint formula, if we're saying that we're looking for the midpoint between 2 points, if we've got these 2 points and we want to find what's right here in the middle, what we're going to do is take the difference, the average between the two x's, and then the average between the two y's. The average, when you have two things, is you add the two up. So add the two x's, divide by 2 because there were 2 of them, and you're averaging. For the y's, find the average of the y's. Add the two y's and divide by 2 because we're finding the average. So the midpoint formula is easy because it's just the average between 2. Let's look at an example when we're given 2 points and we want to find the distance. Here's what I'm encouraging you to do, is to start by writing the formula every time. I know you might start to say, well, I've got the formula right there in front of me. Why do I have to write it? It's just good practice. And if you're not the student who gets everything perfect every time, it's just a really good habit. So we'd write the formula and then write what we know. We know that the x's, or we know the two x's, we know the two y's. And here's what they'd look like. x2, so the x's are 4 and -6. The two y's, -1 and 3. If we plug those in, so the formula, so in place of the two x's, we've got a 4, and watch out with the minus here with the subtraction, because it's -6. 4 subtract -6, so what we're actually going to do is add, right? And then -1 subtract 3. I can change the subtracting to adding the opposite. Adding the opposite. So what do I have now? I've got the square root of 4 plus 6 is 10. So 10 squared. -1 plus -3 is -4 squared. So it looks like the distance is the square root of 100 plus 16, or the square root of 116. And that's it. That's the distance formula. Now, we could sometimes simplify this, and we can certainly find the approximation on a calculator also. Now, if I do the square root of 116, I could see that I could remove a 4, so I could see this as 4 times 29. So that square root is simplified as 2, square root of 29. And then on a calculator, if I do the square root of 116, I get that approximately is 10.8, rounded to the nearest tenth. So you will want to be able to simplify your radical and also approximate it on your calculator, but that's the distance formula. Oh, and I forgot I put this grid here for us. If we want to visualize it, 4, -1, -6, 3. You could see that here's our change in x was the 10 units, and here the change in y was 4 units. So you could see that visually too, and maybe that helps you. And we're trying to find that distance. Let's try another example. In this example, we're going to find the midpoint. So again, good practice is to write the formula. We're going to find the average of the two x's. So add the x's, square it. find the average of the two y's, so add the two y's in, not square it, I'm sorry, I can't believe I just said square it. I wrote it divide by 2, but I'm getting distracted and thinking square. So we add the two x's, divide by 2. That's how we find the average, right? Add the two y's, divide by 2. So we're averaging the x's, averaging the y's. So the x's, let me highlight them to make sure everyone's on the same page here. The x's are the 6 and the 2. The y's are the 8 and the 4. So if I average the x's, I'm going to add 6 and 2 and divide it by 2. Why divided by 2? Because there's 2 of them and we're finding the average of 2 things. So 6 plus 2 is 8. 8 divided by 2 is 4. And then let's find the average of the two y's. 8 plus 4 is 12. 12 divided by 2 is 6. So it looks like our midpoint is this ordered pair 4, 6. The ordered pair 4, 6. And it'd look like this. There's an example of the midpoint. I hope that helps you. Next, let's look at an equation for a circle. Here's the standard form of the equation. We've got x minus h, quantity squared, where h is the x component of the ordered pair for the center of the circle. And we add that to y minus k squared, where k is the y coordinate for the center, and we square that. And that sum is going to equal the square of the radius. When we want to write the standard form of the equation of a circle with a center 0, 0 and radius 7, we could replace the h and the k with 0. So we would just have x squared plus y squared. And that's going to equal the radius squared, or 49. So the equation of the circle would look like this. We could also write the standard form of the equation of a circle with a center at -1, 4 and radius 2. So here we look at the center h, k, h, or let me write the actual center. It's at -1, 4, right? So it looks like h, the x component is -1, k, the y component is 4. So I'm going to write this as x minus -1 squared plus y minus 4 squared, and that's going to equal the radius squared. So I can fill in the -1, the 4, and the radius. Radius is 2, so 2 squared would be 4. Simplifying this, I'd have x plus 1 squared, y minus 4 squared equals 4. And there's the standard form of the equation with the center at -1, 4 and a radius of 2. When we have the equation written, we can pull out the h and the k. Now, remember what that formula looked like. X minus h. Let me pull this out in front. X minus h and y minus k squared. So it looks like, oops, sorry, I didn't mean to scramble that. So it looks like the h, k is going to be h equals positive 3, k equals positive 1. The radius is going to be the square root of the radius squared, or the square root of 36, or 6. So find the center. The center is at 3, 1. And then the radius is 6. Let's look at another example where we want to write this in standard form. And here's the most challenging of these different examples. What we're going to do is complete the square. I'm going to save this last example for its own video. But if you do need any help with writing that, completing the square for that circle, then please come back for that second video and we'll walk through that example.